everyone, and welcome. So excited to have you all here to be chatting a little bit of data sufficiency with me. Data sufficiency is one of my favorite question types to talk about because it is just so core to the GMAT, how it works, how it tries to challenge people, and the idea that at its core, the test is supposed to be a critical thinking test first. So by all means, as you guys continue to jump into the stream, feel free to introduce yourselves in the chat. Let us know where you're tuning in from. If you'd like, you're welcome to provide me with a little bit of context on your experience with the GMAT so far. I've put together a couple of my all-time favorite questions, not just because they're challenging, which for many of them they are, but also because they're challenging for students, even at very different ability levels. So whether you're brand new to the test or you've been at it for a while and are looking to sharpen and fine-tune opportunity areas, in many cases, the challenge on very high-level questions isn't that they're intensely calculative or intensely time-consuming, but rather that they ask us to do just a little more digging into what the question's really asking us to do and what that easiest path to the answer looks like. So we're going to be looking at a couple of examples that shouldn't require you to have a really intense amount of content-driven knowledge, but by all means, as you have any questions about that content-driven knowledge, feel free to let me know and we'll chat through things. But for the most part, these questions are a challenge because they ask us to be critical thinkers. They ask us to pay close attention to the detail. They ask us to do some digging to understand what the question is really asking us in its simplest terms, because if you have any experience with the GMAT so far, you well know that they won't always present that information to us in the most convenient way, and to see what we can do about that info. So let's go ahead and dig in, and we're going to take a look at a couple of questions that really present us with an opportunity to think critically. And for each of these questions, I'm going to go ahead and give you some time to work through the examples on your own before we talk about why I think they're such cool questions and what the takeaways for those questions look like. So I'm going to start us off with an initial example that, if you have some experience with the official materials, may or may not be familiar to you. But either way, I want to go ahead and give you a quick 2 minutes to dig in and see if you can identify the correct answer, differentiate it from our wrong answers, and get at the core of what this question is tasking us to do. So I'll be back on screen in 2 minutes, but in the meantime, go ahead and see if you can break down this question. Hold your answers until we get to that 2-minute mark so we don't spoil it for anyone else. And go ahead and take a look at this first example for me. All right, everyone. So my hope is that this question didn't take you the full 2 minutes that I gave you to tackle. It's pretty conceptual, it's pretty big picture, and ideally, it shouldn't have taken an immense amount of calculation to move through. And that's part of what I like about this question, because despite the fact that it's not the most calculative question in the world, it doesn't deal with some of the most challenging content, it's pretty predictive of how students tend to perform, because students tend to do one of two really powerful things with this question. Either they'll write things off really quickly and go, February and March can't possibly have anything to do with January, and mark things as insufficient. Or on the flip side, they'll get really in the weeds, starting to break down all the different ways that we can break down 66 across 12 versus 11 months. But if we do a little more digging on our question stem, this question becomes extremely efficient and leaves us opportunity to take some of that time and apply it in questions that require a little more analysis. So what's interesting about this question stem, and I know that's pretty open-ended, but that's what I want us thinking about when we first encounter our data sufficiency examples and we're considering what the question is really asking us, because they absolutely did not put that in its simplest terms. And by all means, I know Martin's gone ahead and tossed an answer in the chat. If you have an answer, go ahead and put that in the chat if you'd like to give us a sense of where you came from, or if we got a little nervous because it didn't quite line up, that's all right. Just want to see collectively where we're at. Now, the first thing that jumps out to me here is this 66 and 6, right? Because 66 and 6 are numbers that work nicely together, and that probably isn't an accident, right? If the numbers work nicely together, it's probably because they're trying to tell us something. And in this case, if we recognize that 66 divided by 6 equals 11, right? Or 11 times 6 equals 66. Well, I want to think about what that's meant to indicate to me. Because ultimately, on this yes-no data sufficiency question, there are a whole bunch of different ways that I could answer the question yes, right? A whole bunch of different ways in which I could divvy up these 66 people across all 12 months. There's only one way to answer this question no. What would need to be the case in order to have 0 birthdays in January? According to the information, according to the numbers that they gave me here. What would I need to know to have 0 birthdays in January if we're capped out at 6 birthdays a month and we have a total of 66? Well, if we peel back the layers to this question, if we see what it's really asking us at its core, isn't it really just asking us whether all the other 11 months are maxed out? Couldn't we ultimately simplify this question stem to ask, are all other 11 months maxed out? So if you found yourself breaking down this 66 in a bunch of different ways throughout the answer options, throughout our statements, well, if we take a new lens to our statements, if more of the people in the auditorium had their birthday in February than in March, well, then at the very least, March wasn't maxed out, right? So this is enough information to answer our question. And similarly, if 5 of the people in the auditorium have their birthday in March, well, once again, we're in a position where March wasn't maxed out. We again have enough information to answer our question. And we get to exactly the opposite result that many students identify when they're either going a little too surface level through the question or conversely getting a little too in the weeds. And so again, this is a question that stumps very high performers on a pretty regular basis, because when we're confident and when we're confident that we've seen what there is to see about the question, very often we'll move a little too quickly through the analysis. Because for many students, the tendency is to want to hit a point where we're crunching the numbers as quickly as we possibly can, right? That's how we've done math our entire lives, is by crunching the numbers and, getting pen to paper as quickly as we possibly can. But the challenge very often on GMAT data sufficiency and the GMAT as a whole, given that it is a critical thinking test at its core, is that we need to take the time to understand what numbers we needed to crunch in the first place, what the challenge was meant to be in that question. And often that comes, as surprising as it might sound, from taking a little bit of extra time in the start of the question to ensure that we're answering the proper question, and we're answering the proper question in its simplest form. So I want us to take a look at another example, and you guys did a really fantastic job on that first time around, to show what I mean by that and to see where the GMAT can make this a little bit of a challenge. So once again, I'm going to give you guys 2 minutes to take a look at this question on your own before we take a moment to talk through things together. So go ahead, have at it, take 2, and then we're going to chat about what I like about this question. All right, so for those of you tuning in live, feel free to let me know where you got with this question. Let's go ahead and talk a little bit about what makes this an interesting question, because even if you got to the right answer on this question, there is so much cool stuff that we can learn from it. There's a lot to be had here. Now, first off, we've got these two stains and we're using a rug to cover the two stains. And we want to know whether that rug can be placed to cover both stains. And they've given us this piece of information here, each more than 3 feet from the nearest wall. But then they don't tell us anything about the size of the room in the question stem. And they're not going to tell us anything about the size of the room if we give a quick scan to our statements, which we ought to do just to provide some context on the type of information we're being presented with and what that means we're likely being tested on. So why did they bother telling us that each of these stains are more than 3 feet from the nearest wall? Is it so we'd sit here and start to map out, an x minus 3 or x minus 6 to break down really intense algebra to map out the space that it could feasibly be in? Probably not. So what was the point? Why did this matter to us? Because for many students, one, they'll take a decent bit of time trying to wrap their heads around what use that information presents us with. And two, they'll have a tendency to want to either overlook information or assume that it's irrelevant entirely. There was actually a reason they gave us this info. This each more than 3 feet from the nearest wall served to rule out our edge case, that number that didn't quite comply, or the scenario that didn't quite comply with the way the math would normally work. It ruled out the case where we could say, well, wait a second, what if my stain's all the way in the corner and the circular rug can't reach it? It essentially ruled out the possibility that broke the math. It's the geometric equivalent for asking what x divided by y is equal to and clarifying, by the way, y is not equal to 0, because it would make it undefined. And once we recognize that that's the case, it puts us in a much better position to be able to say, okay, well, I don't really care about the size of the room anymore. These are two stains in infinitely large open space. And now my job is to determine whether I can cover those two stains in infinitely large open space. And it gives us a little more context into what we would need to have the opportunity to answer our question. So what would we need to be able to answer our question? To know whether the rug can be placed to cover both stains. Well, we need to know the size of the rug, and we'd need to know how far apart those stains are. Essentially, the question is asking us, is the rug large enough to cover the two stains and the space between them? Now, pretty quickly, everyone who responded in the chat recognized that neither of these statements independently were going to have a chance of answering our question, right? Just knowing the size of the rug, not particularly helpful to us because it doesn't give us any context about how far away the stains are. They could be an inch away from one another or a mile away from one another because, again, we don't know anything about the size of the room. Just knowing that the centers of the stains are less than 4 feet apart. Also not particularly useful on its own because we don't know anything about the size of the rug. Now, when we put our statements together, here's where you guys had a bit of a divide. When we put our statements together, we know that Jack's rug covers an area of 9 pi square feet, but area is kind of an abstract way of thinking about this question because area doesn't give me a good, dimensional sense of whether or not this rug will cover the two stains. What's going to be the more relevant measurement for that? What measurement would more readily identify whether we can use this rug to cover our stains? Well, the diameter, right? The diameter is essentially the width of this rug at its widest point. And when we know one thing about a circle, we know everything about a circle because circles are symmetrical shapes. And the GMAT loves to test us on symmetrical shapes like squares and circles and equilateral triangles because we can solve for a lot while being given what appears to be relatively little. And in this case, we can solve pretty quickly without a ton of foundational geometry for that radius. Again, if 9 pi equals pi r squared, well, then we know that the radius is going to be equal to 3. And thus the diameter is equal to 6. And if you wanted to, you could actually do the same thing for these teeny tiny stains in the question stem. And applying the same formula would get us to a radius of 1 over 10. But from here, we actually needed to think a little bit more clearly about the math. And the reason we needed to take that next step in calculation was because of this less than. This less than gave me a range rather than a concrete value. And this is a really great thing to look out for when you're breaking down data sufficiency questions, because generally speaking, when we're given a range, it means we want to take that next step in calculation to ensure that the answer to our question is the same anywhere in that range. And in this case, pretty quickly, without a ton of additional math, we can see that if I have two stains that are at their most a little less than 4 feet apart, plus that little 1/10 on the side and that little 1/10 on the other side, well then a rug that is at its widest, 6 feet wide, is going to cover it. Together we have sufficiency. Very nicely done. But I point out this less than because had the question been minorly but impactfully different, we may have wanted to take some different steps or alternatively not taken those steps. So let me ask you guys this. How would this question be different if they gave me all of the same information otherwise, all the same info otherwise, but they clarified for me, by the way, the centers of the stains are less than 8 feet apart? Let me know in the chat here. How would my answer to this question be different if they told me the centers of the stains are less than 8 feet apart? Well, we had sufficiency when we put our statements together because that 4 and change at the very, very most, that 4 and change was smaller than 6. But if I'm in a position where the centers of the stains are less than 8 feet apart, well, they could be 7.99999 feet apart, or they could be 2 feet apart, which means we still have, that's exactly right, yes answers and no answers in that range. Even together, this would not have been enough information. And it's because that range held the potential for both yes and no answers. So one more quick hypothetical here. What if instead they told us that the centers of the stains are 8 feet apart? How would my answer to the question be different then? The centers of the stains are 8 feet apart. I'm getting at something here, I promise. Well, with our first modified statement too, we didn't have enough information because there were both yes answers and no answers in our range. But if they tell us the centers of the stains are 8 feet apart, that gives us precisely one possible situation, right? It gives us exactly one possible scenario. And that exactly one possible scenario is going to answer our question, right? Yes, that's exactly right. So it answers our question with a no. No, the rug cannot be placed to cover both stains. But no is a definitive answer to our yes-no data sufficiency question. So when we're presented with a situation where we can tell based on the statement or the combination of statements that we've been given that there is exactly one possible scenario, we don't need to do the math. We have sufficiency. As soon as we can track to the fact that there will be exactly one possible value or there will be exactly one possible solution, we're done. We have enough information. But when we're presented with an inequality, when we're presented with a range, we need to double check to make sure that our answer remains the same anywhere within that range. So very nicely done. And the other thing that I want to point out that students will often overcomplicate for themselves is the fact that you'll notice that they gave me inequalities where they were less than pi over 100, where it was less than 4 feet apart. But when I looked at the math, when I considered the possibilities, I didn't consider it with 3.9999999, right? Or a little bit less than 1/10. I considered it at the cusp value. And anytime you're not given integer constraints, that's generally going to be the easier and the more foolproof way to go. If I consider this at the cusp value, then I know that my range is anywhere that's a little less than 4 2/10. Whereas if I pick a number that happens to comply with my parameters, well, one, I could miss other values in that range, and two, I could end up making a needlessly calculative question when identifying the range and understanding how my value compared to that range would have made the math a little bit easier. Now, we looked at a couple of cases where kind of just breaking down the question stem was the core, was the crux of the question. But now I want to look at a situation where we're going to need to keep that up a little bit further into our analysis of the question. So we're going to look at our next example here. And once again, going to let you guys lead the way. Once again, going to give you your 2 minutes on your own. I want to see if you can identify for me if and when we can determine what is the value of x. All right, everyone, what are we thinking? Feel free to let me know in the chat. Now, the question stem here is pretty clear. Not a ton to break down with the question, what is the value of x? But they did clarify for us that t and x are integers. Now, at this point in the question, pretty quickly, most students will recognize, especially if they've taken a little bit of time to hone in on their opportunity areas and build the foundations in things like arithmetic and algebra. Most people, when they look at statement 1, will see, oh, well, if x squared and y squared are equal to 4 over 9, well, then I'm in a position where x could be equal to 4 or x could be equal to 2 or negative 2, and y could be equal to 3 or negative 3. So clearly, we've got some positive negative number properties at play here, right? So statement 1 can't possibly be enough information on its own, right? Because we need to consider those negative values. And if that didn't jump out to you immediately, which looks like it didn't for quite everybody, that's okay. Well, then statement 2 should clue us in on that. Because statement 2 tells us x is positive and t is also positive, right? When I see an inequality sign with 0 on the other side of that inequality side, I'm thinking positive negative number properties. Hey, that's okay, that's all right. Again, that's one of the core challenges that we want to know to be alert about in future questions like it, right? We want to consider those positive negative number properties. Now, once we've done so, statement 2, pretty clearly not enough information on its own, right? If anything, statement 2 is supposed to be a tip off to say, hey, did you consider those positive negative number properties? Did you consider the potential that your values could be negative? Now, you may have been tempted, and feel free to update me on how you'd answer this question accordingly. You may have been tempted to look at this and say, okay, individually, not enough information. Individually, not enough information. But what about when I put them together? Surely when I put them together, it tells me that my values are positive. So together I must have sufficiency, right? Well, they did eliminate the possibility for negative values. So sure, we have the potential that we could have something like 2 squared over 3 squared. But is that our only possibility? The other thing that I would note here, outside of considering those positive negative number properties, is that this 4 over 9, this didn't represent a value to me. It represented a scalable relationship. It's a ratio, which means that it didn't inherently tell me that x squared is equal to 4 and that y squared is equal to 9, but rather that they needed to equal some multiple thereof. So couldn't I just as easily have something like 4 squared or 16 over 6 squared or 36? Because 16 over 36 is also going to get me to 4 over 9. And so will the infinitely many other multiples of 4 and 9 that boil down to get us to that ratio. So even together, we're not going to have enough information. And a lot of students, even very high performers, will miss that because they let their guard down when they think they've done something interesting with the question. They'll go, oh, I got it. Positive, negative number properties, no problem. Tackled this question, on to the next one. But we need to be sure that even, and I would argue especially, when we feel like we've done something well with the question, when we feel like we've effectively tackled something or we've seen what there is to see with the question, that we keep on alert, because in many cases, high-level questions will test us on our ability to enthusiastically and consistently take that attention span throughout the entire question. So that's exactly what this question was testing us on. And again, if you stumbled a little bit over, answer option A, well, that's probably a good sign that as you're encountering these questions, we want to be inventorying what we know, but just as importantly, what we don't know about the example. And in this case, the don't know came down to the fact that we didn't know anything about the positive, negative nature of our values until we got to statement 2. So even though we want to analyze each of the statements independently first, there is something to be said for the fact that when another statement gives us a really helpful hint, a clue, a takeaway about the nature of our first statement, well, we want to consider that. We need to keep that in mind when we consider what values to assess, what numbers to pick if we're going to pick numbers, and what the question's truly tasking us to do. So, very nicely done, and thanks for jumping in the participation in the chat. Let's go ahead and take a look at our next one. I want to make sure we've got time for several additional examples here because there are some good ones. Now, again, I want you guys to take a look at this question on your own, and I really want you to take a moment to consider that front-loading the time on the analysis that I've mentioned in the previous couple of examples, right? Taking the time to break down and understand what the question is really tasking us to do, what it's really asking us in its simplest form, and what it's telling us. So, once again, go ahead, take 2. All right, everyone, if you're feeling brave, go ahead and let me know in the chat where we got with this question. And let's talk about why I think it's so interesting. First off, it's interesting because there are about 4 or 5 other questions just like it in official material. In some cases, GMAT authors will lean on some of the same structures. And while the test isn't memorization driven by any means, we want to make sure that we can understand why structurally they set stuff up the way that they did. And this is a really great example of exactly that. So if Michael arranged all his books in a bookcase with 10 books on each shelf, I'm going to call the original number of books B, just to give it a name. What do I know about B? Well, if we're arranging it in a bookcase with 10 books on each shelf and no books left over, what does that tell me? It seems like it's telling me a little something about the divisibility. It tells me that B is a multiple of 10, or it's divisible by 10. Now, we took that B books and we added 10 to it. Michael acquired 10 additional books. And now he arranged his books in a new bookcase with 12 books on each shelf. So what do we know about B plus 10? Yeah, we know it's divisible by 12. What else? What else do we know here? It's divisible by 12. It's also going to be divisible by 10. Now, this idea of universal divisibility is one that is so often underlooked in GMAT Quant. And it is that we started with a multiple of 10, and we added 10 to it. If I start with particular divisibility, and I add or subtract in increments of that divisibility, I'm going to maintain divisibility. We know that this value is both divisible by 12 and divisible by 10. Now, what do I know about numbers that are both divisible by 12 and divisible by 10? Because even if you got this question right, and several of you guys did, very nicely done, well, there's a lot of cool stuff we can learn from it. Because chances are, most of the students who get this question right take a less than ideal path through it. And a lot of times it involves a lot of plugging in numbers and adding 10 to that number and then testing the divisibility of the new value. And we did not need to do any of that. We want to treat this like a Sudoku puzzle and work from what we know the most about. And as it stands, we know the most about that ending number. And in particular, we know that if it's divisible by 12 and divisible by 10, it's divisible by the least common multiple of those two values, or 60. Now again, whether you broke this down using prime factorization or maybe just reason through the fact that the first multiple of 12 that is also a multiple of 10 has to be 60, what does this now tell us about our question? Why is 60 relevant? Why did I take the time to move us through all this divisibility and get to the value 60? Well, I did that because my statements that are just in the form of ranges, of inequalities, were going to be a lot easier to tackle if I knew my limitations from their most specific form. And the most specific way that I can identify that divisibility is with the ending number of books. I know the ending number of books has to be some multiple of 60. So really my question becomes, is there one multiple of 60 or more than one multiple of 60 in my range, right? Now, one thing I do want to make note of is the fact that they gave us the information in terms of before. Now, this wouldn't actually have tripped you up on this example, but there are 2 or 3 other examples just like it that are a little bit trickier where it might have. If before Michael acquired the 10 additional books, he had fewer than 96 books, that means that after, he had fewer than 106, right? Well, do I have one multiple of 60 or more than one multiple of 60 that falls in that range? The next multiple of 60 is 120. I have exactly one possible multiple in that range. So as a couple of you guys noted, yes, statement 1 was enough information to answer our question. Now, statement 2 gives us a range for the starting number of books as well, but it tells us before Michael acquired the 10 additional books, he had more than 24 books. Now, I could do the translation to after if I wanted to, but hopefully we notice here that this is a really open-ended and in fact an infinitely open-ended inequality. I'm going to have infinitely many ways to fill in the blanks here. Now, this is meant to trip up students who perhaps, take a little bit too much time to consider that 60 is between 96 and 24, but statement 2 doesn't give me enough information. It doesn't present me with one possibility. It presents me with infinitely many. And different variations of this question might task us to look to before versus after, or identify whether the range was open-ended or closed-ended. And in this case, statement 1 presented us with enough information in a way that was very efficient, very quick and easy to see, if we had taken a moment to break down the information as it stands, to recognize the divisibility, to recognize what the question stem at its core was trying to tell us. And that's a very consistent trend on data sufficiency examples, where if we've taken the time to break things down and see in its simplest form what information we're being given and what information we're being asked about, the actual math becomes pretty straightforward far more often than not. So let's keep that theme going when we take a look at this next example. And in this next example, again, I want you guys to just take your 2 minutes, lead the way with it, and I will preface this and say there are several different ways to tackle this question, as is often the case on our data sufficiency examples, and they are not all created equal. So with that, not as ominous as I meant, tone, I'm going to let you guys go ahead and dig into this next example, take 2, and then we'll talk about it. All right. So once again, if you're feeling brave, go ahead and let me know where you got in the chat. And let's talk about the different ways that we could consider what this question is asking us and what it's asking us to do. So pretty quickly, value question, we're asked for the value of n. And we're given information that presents us with some potentially, not so linear equations. And we could absolutely, certainly represent this question algebraically. If 69 plus n and 94 plus n are the squares of 2 consecutive integers, we absolutely have the opportunity to represent that using a couple of unknowns by noting that 69 plus n is some number squared, which we could refer to as just x squared. And thus 94 plus n would need to be the next perfect square. So 94 plus n equals x plus 1 squared. And if we do that pretty quickly, if we start to break down the numbers a little bit, if we put this into a more convenient form, because when I have something like the square of a sum, which was given to us over here, you can count on the fact that the other format's going to be the more useful one to utilize. So if I represent this in expanded form, and I have my x squared plus 2x plus 1, all I did was FOIL first, inner, outer, last, or if you've taken some time to become acquainted with common algebraic equations, you could probably see and swap that a little faster. Well, then hopefully we can see that if we were to line these up, well, then elimination tells me that everything other than my x is going to cancel. And as soon as I get to that point in the question, it would be an absolute waste of time to continue to crunch the numbers and do the math, because if I know that there's exactly one possible scenario, exactly one possible value for x, well, then I know there's going to be exactly one possible value for n as well. And furthermore, if I can draw that conclusion for statement 1, I can certainly do exactly the same thing for statement 2. If all I do is pick up a couple of constants and put a couple of different constants in their place, well, then I'm again going to have enough information to answer my question. But we didn't actually have to do all that math. If we think conceptually about the relationships that have been given to us, about the number sense and how that number sense applies, there's a much easier way to think about this question. Now, if 69 plus n and 94 plus n are the squares of two consecutive integers, well, 69 plus n and 94 plus n, even if I don't know n or its scale, they're 25 away from one another, right? Because that's the difference between 69 and 94, and the n's are going to cancel. So if I know that these two values are 25 away from one another, let me ask you this. Is there one situation or more than one situation in which two consecutive perfect squares will be exactly 25 away from one another? And in many cases, we can weed away a lot of the math that we might otherwise have done in a question by asking exactly that question, right? Is there one way to get there or more than one way to get there? I posed the same thing a few questions earlier. If they're exactly 25 away from one another, and I think about the way exponential relationships work, well, 1 squared and 2 squared are closer to one another than 2 squared and 3 squared. 2 squared and 3 squared are closer to one another than 3 squared and 4 squared, and so on and so forth, all the way up the number line. So there will be precisely one possible situation in which these two perfect squares are exactly 25 away from one another. Because as my numbers get larger in scale, that gap grows. And as my numbers get smaller in scale, well, it shrinks. So there were several ways to think about this question. We could even have utilized the fact that if we know the difference between the two is 25, well, 25 as a metric for perfect squares can really only be accomplished one way. When I move up or down consecutive perfect squares, all I'm really doing to move up or down a consecutive perfect square, if I think about the number sense and if I think about proximity to easy to work with values, is I'm adding the number that I started with and I'm adding the number that I got to, which in this case just so happens to be 12 and 13. If I take 12 squared and I add 12, I now have 12 times 13. If I add 13 to that, well, that's just 13 squared, right? And to do that, if I add 12 and I add 13, well, that's the situation in which I add a collective total of 25. Now, again, I say this not to dig in and test every feasible possibility for how to break down the numbers, but that really any one of these would do. And in many situations, students get this impression that people who are really successful in GMAT Quant are people who have just crunched every single number under the earth, seen every question there is to see, and have impeccable math skills at the root of algebra, at the root of how they're doing the math and understanding the foundations. And yeah, that's a great start. But in many cases, GMAT questions will punish students who are very single-minded in how they attack questions, and they'll reward students who are able to be flexible. And so recognizing that we have several different methods of attack for any given question that we encounter puts us in a position where we can be flexible, where we can be agile, and we can take whatever approach technique is going to be the most efficient based on our analysis in that first, we'll say 15 to 20 seconds. And it allows us to be successful even on questions where crunching the numbers may not have been the best way to go. Now, the algebra wasn't impossible here by any means, but the better we understand the relationships between numbers and how those numbers work together, the more readily we're going to be able to apply that even when the numbers are a little trickier or the algebra would have been a little more intense. So let's look at another one. And again, I want to see what you guys do with this one. And this next one, 2 quick things. One, shouldn't take you 2 minutes. It is not a 2-minute question. If it does, no worries. We could talk about how to up the efficiency when we save a couple of minutes for Q&A at the very end. But really, what I'm looking for you guys to do here is to identify how this question presents us with a unique advantage to move past it very quickly and save time for the trickier stuff. Because yeah, there's a little bit going on here, and there's a lot that we need to dig into and recognize. But this question presents us with a really, really great set of opportunities to work smarter, not harder. So go ahead and take the next 2 minutes to do so. All right, everyone, what do we think? Did you guys get to an answer? Are you still crunching a couple of numbers? Because this is another case where even if you might have been on the right track, even if you might have been doing correct math, there was definitely the potential to do too much of it. Because you may have noticed, or hopefully you noticed, that I'm recycling from a takeaway that we looked at in that very first example. And that was that when numbers tend to work nicely together, it's probably not an accident, right? We're probably being asked to recognize why that's the case and to be able to recognize how to apply the math in its simplest form. So if I were to set up the algebra for this question, where we have 126 total ornaments, well, that 126 is going to be equal to 6 times the number of small boxes, which I'm going to represent as S. I know my S's might look a little like 5s and my 5s a little bit like S's. So take whatever lead you'd like in terms of your variables. But I will say, getting out of the habit of calling all of your variables X, Y, Z, and ABC is a really great habit to get out of, because in many cases, the challenge associated with the question, especially as you get into things like problem solving, will come down to making sure you're answering the right question. And you'd better believe that the answer to the other variable will also be among your answer options. So I'm going to put S for my small boxes, plus I've got 24 times my large boxes, which I'll represent as L. Now, I don't want to sit here and multiply things by 6 and multiply things by 24 and see where that totals me to 126. So can you guys see anything interesting about our numbers? Our coefficients, 24 and 6, and that constant over there, 126. Anything seem noteworthy that we may want to pay a little more attention to? Because again, the more that we can whittle this down into its easiest workable terms, the easier our analysis of our statements is going to be. So 126, 6, and 24, those are all multiples of 6. I can divide both sides of my equation, getting me to 21 is equal to S plus 4L. And at this point, the process of plugging in options, considering those options, mapping those options back to the stem becomes so much easier because we're working with terms in their simplest form, and hopefully we're considering divisibility. Because I mentioned a little bit earlier that we need to make sure we're taking effective inventory of what we know, and just as importantly, what we don't know. And one thing I would point out in the context of this question that will very often be the case when you're dealing with algebra questions, when you're dealing with things like ratios, even our percent questions, we want to consider cases where we're given integer constraints. I can't have 0.346 of a large box or half of a small one. These needed to run in integer values, even in its simplified form, which means that if fewer than 4 of the boxes contained 6 ornaments, well, theoretically, that means my integer possibilities are 3, 2, 1, and 0. But could I have 0 of the boxes contain 6 ornaments? If I plug in 0 for S, well then 4L equals 21, and L is not an integer. That's not going to work for me. Now if S is 1, then 21 minus 1 gives me 20, and I'm able to divide, get to an integer value. We could have 1 small box. But 2 and 3 are going to run into exactly the same issue I ran into with 0. If I subtract 2 from 21, if I subtract 3 from 21, I'm going to get non-integer values. This isn't going to work for me. Now, here's where beginner students will get a little tripped up on the language. We have exactly one possible value. We've narrowed it down. We've identified that the only possible number of small boxes is 1. If we know the number of small boxes, we certainly know the number of large boxes. Statement 1 is enough information to answer our question. Now, if we take the same line of thinking into statement 2, I would note that we no longer have that same parameter, that same constraint, that same restriction that told us that 4L needed to break down to give us an integer value, because now I don't have a coefficient in front of S. So if more than 3 of the boxes contain 24 ornaments, theoretically we have 4 boxes or 5 boxes and so on and so forth. But I'm actually going to stop there, because as soon as we can determine that we have more than one possibility, we're done. We don't have to do anything else from there. Now, could we have 4 large boxes? Sure. 4 times 4 is 16. Take 21 minus 16. We're left with an integer number of boxes for S. Could we have 5 boxes? Sure. 4 times 5 is 20. 21 minus 20 again gives us an integer value. Now, we are limited there because we can't have a negative number of the other box. Again, we were given non-negative integer constraints. And paying attention to those constraints and what those constraints mean to us is going to make a pretty big difference. But it did tell us that we had more than one possibility for that large number of boxes, meaning that statement 2 wasn't going to cut it, wasn't going to be enough information. So very nicely done. Yes, it was once again A. And that wasn't an intentional emphasis on A as the answer, but it was a good opportunity to compare similarities and differences across our statements and see what they were trying to challenge us with. And speaking of exactly that, I have one more example I want us to take a look at before we move forward and we start to talk just kind of big picture takeaways. So one more time for the final time in this hour, you guys have been hanging here with me. Let's go ahead and take a look. I'm going to let you guys lead the way. Take 2. All right, now for our final question of the day, let's talk about it. And once again, if you have an answer, whether you're confident or you just have a best guess, let's go ahead and see that in the chat. We want to know if R and S are positive integers, is R over S an integer? And once again, we're in a position where the language that was given to us probably wasn't the ideal way to represent this information. Because if I give a quick scan to my statements were given to me in terms of factors. So is there a way that I can reframe what this question is asking me in terms of factors and multiples? Well, in order for R over S to be an integer, what would we need to know? Well, in order to take R and divide it by S and end up with an integer, we would need R to be divisible by S. So really we're asked, is R divisible by S? And I could take that a half a step further. In order for R to be divisible by S, we would need S to be a factor of R. So ultimately, we could rephrase this by asking, is S a factor of R? Now, at this point, we're going to go ahead and take a look at our statements, and we're going to consider inventorying what we know and putting it into its simplest terms. Now, we're told that every factor of S is also a factor of R. And yeah, this is getting a little bit quant vocab-y for our final question, but in a way that's going to be really essential to keep in mind, because very often the difference between a correct answer and a convincing wrong one will come down to precision in language, to reading and interpreting precisely what they said rather than just what it sounded like or how we interpreted what was relevant about it. Because they've told me every factor of S is also a factor of R. And sure, I could pick numbers here, but I shouldn't really need to, because what's the largest factor of any value? Every factor of S is also a factor of R. The largest factor of any value should be itself, right? The largest factor of 15 is 15. The largest factor of 30 is 30. So if every factor of S is also a factor of R and S is a factor of S, then S must also be a factor of R. I'm going to get to an integer. I have enough information to answer my question. And a lot of students will get to that in statement 1, and then they'll find themselves hitting a bit of a stopping point. We had a little less participation on this one, so I'm assuming at least a couple of you guys did. They'll hit a bit of a stopping point on statement 2, because when we read through statement 2 appears to give us something a little bit different. But it can be a little tricky to recognize whether it is impactfully different or unimpactfully different. So if every prime factor of S is also a prime factor of R, well, we can't necessarily draw the same conclusion that we did out of statement 1, right? Because we don't know that S is a prime number. But if we wanted a next step from here to say, all right, this seems to be giving me something different, and I'm not sure if it's impactfully different, but I'd like to understand whether or not it is. This would be a good opportunity to pick some numbers. Now, number picking is a really fantastic strategy in GMAT Data Sufficiency when it's done well. It can be extremely time-consuming when it's done poorly. And so we want to make sure that if we are going to pick numbers, we're going to pick numbers with intention. On a yes/no data sufficiency question like this one, we're going to pick numbers with the intention of trying to answer the question yes and the intention of trying to answer the question no, so that we can really delineate the difference here between statement 2 and what we saw in statement 1. So if every prime factor of S is also a prime factor of R, that's saying something a little different than statement 1. It's also saying something a little different than if we were to have said that the prime factorization of S is within the prime factorization of R. Because, for instance, numbers like 6 or 3 times 2 and 12 or 3 times 2 times 2, well, those share the same prime factors, 3 and 2. They have different prime factorizations. And as soon as I can see that, again, precision in language of what statement 2 is telling me, it should become a little more clear how I want to go about picking numbers. Now, it should be very easy to answer the question yes, right? It should be very easy to address a situation where R is in fact divisible by S. I could be in a situation where maybe R was equal to that 12 and S was 6. 12 divided by 6 is an integer, 6 is a factor of 12. Can I answer the question no? Given what I just mentioned about prime factors, of every prime factor of S is also a prime factor of R. I gave you an example, and we purposely fashioned an example where 6 and 12 shared all the same prime factors. So couldn't we just as easily reverse this? Couldn't R be 6 and S be 12 and answer the question no? And as soon as we can, with intention, answer the question yes, with intention, answer the question no, we've disproven our sufficiency, right? We do not have enough information to answer our question, and we can key in on the importance of that precision in language and how it impacted the way we went about statement 2. So one other thing that I'd like to mention, and we did not by any means go through absolutely every structure and strategy out there, is the fact that when we're breaking down and identifying the best approach, we want to consider how to continue to leverage all the information we've been presented with us, whether we're going to look at a question algebraically, whether we're going to pick numbers, but pick numbers with intention, or kind of sit back and take a more passive approach toward thinking critically about what the question was asking us and whether there was one way to go or more than one way to go, as we did with several of our earlier examples. So if you have any questions on any of the examples that we went through, definitely feel free to let me know. There are certainly some structures that we maybe didn't have the opportunity to take a look at just yet today. There is way more where that comes from when it comes to our data sufficiency strategy. We want to make sure that we're looking for opportunities where 2 statements maybe say the same thing in slightly different terms, or a statement that's clearly and obviously insufficient is there to try to indicate something to you, there to try to tell you something. Like those of you may have seen when we went through the explanation and you got a little tripped up over the positive negative nature of that fraction in the second or third example that we went through. But the big picture takeaway that I want to make sure we're keeping in mind is that at its core, data sufficiency questions are meant to be critical thinking questions first. There's a ton of overlap between the way we tackle these questions and the way we might think about something like a critical reasoning example. In fact, there are some structures that are pretty much identical with math as the foundation rather than language. And if we think about these as critical thinking questions and we kind of Sudoku puzzle our way from what we know the most about back, we put ourselves in a position to not just get the right answer, but to get the right answer as efficiently and as confidently as possible. Because in many cases, some of the challenges that students will run into are the fact that they're not getting every data sufficiency question wrong, but they're moving through questions with maybe 60 to 80% confidence that they're on the right track. And we want to know what steps we need to be taking to ensure that 100% confidence and what steps aren't contributing toward that, like we saw in that earlier example. So if you guys have any questions for me, whether it pertains to the examples that we went through today or even just bigger picture strategic examples around data sufficiency, feel free to let me know in the chat. If you're watching this recording, feel free to comment. I'll be sure to check in and answer any questions that you all have. The other thing that I do want to note is that we have a course coming up. Our veteran instructor, Chris Kane, who is the head of test prep, will be starting a course next Wednesday. So definitely feel free to check out the information there. And in fact, I'll be sure to pop that into the description for this particular lesson. And you'll get way more where this comes from in terms of breaking down and thinking about questions strategically. Because again, the GMAT is meant to be a strategic test. It's not meant to be a collective test of everything that we've ever learned in math or everything that we've ever learned in grammar. Instead, it's meant to ask us to look at the big picture, to think critically, and to effectively leverage the information in front of us. We want to make sure we're really keeping that in mind. Oh, really great question. Fantastic question. So the question here is, what's a good way to avoid traps? So thinking you're knowing the answer, but you falter and overestimate sufficiency or falter and underestimate that sufficiency. So in a situation where you tend to fall into traps, and especially when you're in a situation where those traps feel really obvious after the fact, right? You can look at the explanation and go, oh, I should have seen that. How did I not see that? Well, in many cases, you'll find that those traps, even if they're on a variety of different content areas, will come down to a lot of the same root structures or root causes. So one of the best ways to make sure that you are identifying traps, your tendencies to fall into those traps, and how to route past them is by recognizing the nature of the mistakes that you make. Because too many people will go through data sufficiency questions or questions in general, and they'll say, oh, I see why I got it wrong. Now, like, I see the explanation and I understand it now that I've read through the explanation. But we want to make sure that we're in a position to where if you were to encounter not the same question, but another question that dealt with the same takeaways, that you'd be able to effectively apply that information. And we recognize that by identifying the nature of where we disconnected from that answer. So essentially looking at the explanation, comparing it back to your approach, and really clearly identifying where you failed to move forward or where you went a different direction with the question. Because that really specific feedback is going to let you know, one, where to target your practice. There's a huge difference between missing a data sufficiency number properties question because you didn't know how number properties work versus being perfectly comfortable with number properties, but not knowing how to apply that on a number properties data sufficiency question that tasked you to pick numbers, right? Or being perfectly comfortable with right triangles, but not knowing to draw that particular line and create that particular right triangle. So being able to log, understand, and bucket the types of mistakes that you're making is one really great way to avoid continuing to make those mistakes because you can understand the root of them. You can look out for certain cues that you should have been more conscious of and will be in the future. So if you missed the positive, negative nature of that earlier example, well, taking a look at the parameters that are given to you and making either physical or mental note to say, here's what I've been told about the nature of my values. And just as importantly, here's what I haven't been told. Using opportunities like the existence of an inequality sign with 0 on the other side in the other statement to say, wait a second, have I considered positive, negative number properties? And for a lot of students, the recommendation that I'll make is that in addition to any sort of notes or cheat sheets or formula-driven information that you've put together to try to remember and try to apply more effectively in the future, putting together a quick one-pager, kind of a living document of sorts of just the handful of things that you need to be most conscious of on a question-by-question basis is a really great way to go as well. So being able to recognize, hey, I got burned by that question because I didn't see that inequality sign with 0 on the other side meant I needed to be considering positive, negative number properties. Noting that down will make it much more clear for you to recognize the next time around, hey, I got to be considering those positive, negative number properties. So definitely far more than just those foundations, but those will give you a couple of good introductory steps on how to better track not just your mistakes, but why you're making them, what you need to be more conscious of in the future, and how to target your practice in the meantime. So hopefully that's helpful. If you guys have additional questions for me, definitely feel free to let me know. Even once we wrap up this live stream, by all means, feel free to continue to chat my way. I'll hang out in the chat for a little while. And those of you guys checking out the recording, feel free to comment and I'll get back to you there. In the meantime, thank you guys so much for joining. Thank you for all of your participation. Hope you enjoyed going through a couple of my favorite data sufficiency examples. And I hope to see you guys again soon. Bye, everyone.